Welcome to Easy Math, making math easy. In this channel, we are learning mathematics the traditional way. We are learning the concepts in depth. No shortcuts, no techniques, but the concepts. According to my understanding, according to my belief, our mathematicians had learned math this way. They hadn't learned it using any shortcut methods. So, I believe that if students learn math this way, they will be very strong in their concepts. They will come up with their own shortcuts, own techniques. Okay. Without any further delay, let's move on to our video in which we are going to talk about trigonometric identities today. Similar to our algebraic identities, we have identities in trigonometry also. So we are going to look into such identities today in today's class. There are three very, very important identities with which you will be able to solve any given identity in trigonometry. This is for grade 9 and 10. So if you remember these three identities, it is enough. Okay. So the first most important identity, let's not memorize it. So let's first derive it so that you understand the concept. Okay. So we are dealing with right angle triangles. You all know that. So the very, very important property of a right angle triangle is the Pythagoras theorem, according to which the square of the length of the hypotenuse is equal to sum of the squares of the other two sides, right? The length of the other two sides. That is AC square. According to this triangle, AC square is equal to AB square plus BC square. Am I right? Okay. So now what we are going to do is we are going to divide every term of this equation. Okay, the equation that we have, the property that we have, we're going to divide every term by AC square. Okay, so you all know this, right? So if you do anything to one particular term of the equation, to maintain the balance, the same thing you will have to do to every term, right? So I'm going to divide throughout by AC square. So dividing throughout by AC square. What do we get? We get AC square by AC square equal to AB square plus AC square plus BC square by AC square. So this is not wrong because I'm doing this to every term of the equation and this retains the balance of the equation. Okay. So now AC square by AC square is equal to 1. Am I right? So AC square by AC square is 1. That is equal to AB square by AC square. What is AB square by AC square? AB is the, let's say the C is theta. Okay, C is theta. So according to this angle, AB by AC is nothing but sine of theta. Correct? So sine of theta, the whole square, because it is AB square by AC square plus BC square by AC square. BC square by AC square can be considered as BC by AC the whole square, correct? So what is BC by AC? BC by AC is nothing but the adjacent side by the hypotenuse side, right? The adjacent by hypotenuse, that is going to be cos of theta the whole square. Okay, so you know that this can be written as sine square theta plus cos square theta. So the first identity is what we have got now. That the sine square theta plus cos square theta is 1. The first and foremost identity, which is very important, is sine square theta plus cos square theta equal to 1. Okay, so now we have got this identity that sine square theta plus cos square theta is equal to 1. Now, let's move on, deriving the next identity. So what am I going to do? I'm going to alter this identity a bit. So what I'm going to do is, I'm going to divide this identity throughout by sine square theta. Okay, so what will I get? Sine square theta by sine square theta plus cos square theta by sine square theta, right? Every term has to be divided by sine square theta to preserve the equality, the balance between the left hand side and the right hand side, okay, according to the rules of mathematics. So I'm going to divide every term by sine square theta. Okay, so what happens? Sine square theta by sine square theta is equal to 1. Okay, plus cos square theta by sin square theta is nothing but your cot square theta, correct? I hope you all remember all this. If you've forgotten, please do go back and visit those videos and then come back here, the previous videos, and then come back to this video. Okay, is equal to 1 by sin square theta. 1 by sin square theta is a reciprocal of sin square theta. That is nothing but cosecant square theta. So this is our next identity that says 1 plus cot square theta is equal to cosecant square theta. Okay, let's put it here. Okay, so 1 plus cot square theta is equal to cosecant square theta. Okay, so now let's move on to derive the third identity. So we'll again take the first identity. First, we divided every term by sine square theta, right? So this time we are going to divide throughout by cos square theta. So what happens? I'll get sine square theta by cos square theta plus cos square theta by cos square theta is equal to 1 by cos square theta. Okay, this identity, I'm dividing every term of the identity by cos square theta to preserve the equality, meaning the balance between the LHS and the RHS. So what is sin square theta by cos square theta? That's nothing but tan square theta. Plus cos square theta by cos square theta is 1 and 1 by cos square theta is secant square theta. So this is going to be our third identity. That is tan square theta plus 1 is equal to secant square theta. So we've got our three main identities. Okay, so we are going to rearrange these terms to get two more sub identities under every main identity. Okay, so what we're going to basically do is just going to transpose the terms and then rewrite it so that we get few more identities. Okay, so now what is the sub identity? Meaning, what is the identity that we can derive from this? Two more identities can be derived. So I can keep sine square theta on this side and then write sine square theta is equal to 1 minus cos square theta. Similarly, I can keep cos square theta this side and then write 1 minus sine square theta. I can take sine square theta to the other side and write cos square theta is equal to 1 minus sine square theta. Correct? So we have these three identities here now. Sine square theta plus cos square theta is 1. Sine square theta is equal to 1 minus cos square theta and cos square theta is equal to 1 minus sine square theta. Okay. Similarly, we'll rewrite the second identity and to get two more identities here. Okay. So now, what's the first identity that we will get? We will transpose cot square theta. We'll keep cot square theta here and then we'll transpose 1 to the other side. Cosecant square theta minus 1. So cot square theta is cosecant square theta minus 1. This is our first identity. And then the second identity is 1 is equal to cosecant square theta minus cot square theta. Okay, this is our second identity. Now, with this third main identity, we can derive two more. The first one is 1 is equal to secant square theta minus tan square theta. And second identity is going to be tan square theta is equal to secant square theta minus 1. So now how many identities in all? We have 1, 2, 3, 4, 5, 6, 7, 8, 9 identities. And these are not difficult to remember. Okay. So if you remember these three main identities, the others will follow. Correct. So during the examination, I suggest that you write down these three identities in the rough column so that you don't make any mistakes. And the other identities can be derived by transposing. Okay, so as and when you practice, more the number of identities you try to solve and more the number of problems that you try to solve, these identities slowly will, you will slowly memorize these identities. You'll get used to them and then you need not worry. You will be able to remember them at the right time. Okay, so only practice. Practice makes a man perfect. We'll have a quick recap of what all we saw today, the identities that we had seen in this video. The first identity is sine square theta plus cos square theta. Cos square theta is 1. Okay, sine square theta plus cos square theta equal to 1. From that, we also derived that sine square theta is equal to 1 minus cos square theta and cos square theta is equal to 1 minus sine square theta. Okay, the next identity is 1 plus cot square theta is equal to cosecant square theta. So from that we come to know that cosecant square theta minus cot square theta is 1 and cot square theta is cosecant square theta minus 1. is equal to cosecant square theta minus 1. Cos square theta is equal to cosecant square theta minus 1. Okay. The third one is tan square theta plus 1 is equal to secant square theta. Secant square theta minus tan square theta is equal to 1. And tan square theta is equal to secant square theta is minus 1. So these are the most important identities that you have to learn. And then in the next video, we'll see how to solve problems based on this. I hope you enjoyed the session today. Please keep a notebook and note down all the identities and solve as many identity based problems as you can. So this will help you not only remember the identity, but also will expose you to a variety of problems. So wherein you will get a lot of confidence before the examination. Yeah. So practice, practice. Practice is the mantra that makes math very, very easy. If you like the classes, the sessions, please do click on the like button, subscribe to my channel, and share my videos. If you have any doubts, please feel free to put it on the comment box. It will be definitely addressed. Thank you.